Right, these are our notes on imaginary and complex numbers, square root principle and completing the square, and then quadratics with complex solutions. First, we're going to look at the imaginary unit, and this is where we're going to talk about imaginary and complex numbers. Your imaginary unit is defined as I equals the square root of -1. This was created to help us deal with if we have a negative under an even index radical, and we have a negative radicand, so we can't, we've always said before, if you're taking the square root of something, it can't be a negative number under the radical. But with an I, or the imaginary unit, this enables us to keep that negative under the radical. And I equals the square root of -1. I squared equals -1. I to the third power equals -I. And I to the fourth power equals 1. So the first thing we're going to do is simplify a radical when we have a negative number under the radical. To do this, I'm going to break down the square root of -41. I'm going to turn it into the square root of -1 times the square root of 49. And because I did this, we know that the square root of -1 is equal to I, and the square root of 49 is 7. So my final answer, and we'll write it with the number first and then the I, will be 7I. For B, again, we're going to do it the same way, except -50 isn't a perfect square, so I'm going to change it into the square root of -1 times the square root of 25 times the square root of 2. Again, -1 becomes I. The square root of 25 is 5. So I have 5I. And then the square root of 2 we can't do anything with, so we'll leave it as is. Right now we're going to look at the square root of -108. And I know for 108, I'm going to use the square root of -1 times the square root of 36 and the square root of 3. So when I break this down, the square root of -1 equals I. The square root of 36 is 6, so I'll have 6I. And then the square root of 3 we'll leave alone, so we have 6I square root 3. Next, what we're going to do is we're going to simplify when we have higher powers of I. So in this case, I have I to the 15th power. The way that you calculate any higher power of I, our answer is always going to equal either I, -1, -I, or 1. And what you want to do is to convert I, a higher power of I, to a lower power. You take the closest multiple of 4 and subtract this from your exponent, and your leftovers or your remainders will be your solution. So here I have I to the 15th power. And what I'm going to do is I'm just going to take, and right here, I'm going to take my 15 and divide it by 4. Now I know that 4 times 12, or 4 times 3 gives me 12, and that's the closest to 15. So I'm going to put the 3 in there. Subtract my 12, and I have a remainder of 3. So my answer here for I can break it down like this. I have I, and I know that I can do 4 times 3, or I get 12, and then I have a leftover, or an extra amount, of 3. So the I to the 12th power will equal a 1 because 4 goes into it evenly. The 3 left over is going to give me I, or I to the 3rd power, which is equal to negative, or the opposite of I. We're going to do the same thing here with B. And we have I to the 562nd power. So I'm going to take and divide 562 by 4. 4 goes into 5 one time. So we'll subtract our 4, we get 1 left over. Bring down our 6. 4 goes into 16 4 times. Subtract our 16. We have 0, and then we bring down the 2. 4 goes into 2 0 times. So if we simplify this again, we have I, and we can make 140 groups of 4, which again, when we make those 140 groups of 4, that turns it into a 1. And we have a remainder left over of 2. So it's really, we're evaluating I to the 2nd power here, and that is going to equal a -1. So it's the same as saying we have I to the 4 times 140 power, or 140, plus 2. And that is how we figured out our answer would be a -1. For C, first thing we want to get rid of is that negative exponent. So we're just going to simply do what we always do to remove those negative exponents and take the reciprocal. So I'll have 1 over I to the 84th power. And now I'm going to take and divide 4 into 84. And it goes in 8 twice. Bring down by 4. Goes in 1. So we have I, that's 1 over I to the, that would be 4 times 21st power. There is no remainder. And so because it goes in evenly, it would be I to the 4th power. And we're going to have 1 over an I to the 4th power equals 1. So 1 over 1, which gives me 1. And that's it for there. Now we're going to look at performing operations with I, and we're going to write our answer in standard form. And standard form, when you're dealing with I, is going to be A plus BI. In other words, they want the real number first and then the imaginary term second. Here I'm doing addition with 2 binomials, and it's really just like combining like terms. So I'm going to combine my constant terms first, and 3 plus 4 will give me 7. And then I'm going to combine my imaginary terms, or my complex terms. And I have -2i plus 5i, which will give me -2 plus 5 is a +3, so it would be plus 3i. Then we are going to take a look at B. Now with B, remember we have that negative outside the set of parentheses here. So it's 3i minus 7i minus, which is like a -1 there. We have to distribute that negative to everything on the inside, which means take the opposite. So I'm going to have 3 minus 7i, a negative times a positive, so -1 times +16 gives me -16, and a -1 times a -13i will give me +13i. And then we're simply going to combine like terms like we did before. So 3 minus 16 will give me a -13. And -7i plus +13i will give me a +6i. And because they're not like terms, we can't do any more. We're done. For C, we are multiplying 2i times the binomial 5 plus 2i. We are going to do our distributive property here. So we're going to multiply the 2i times both terms on the inside. 2i times 5 will give me 10i plus, and 2i times 2i. When we multiply our i's, it becomes I squared. 2 times 2 is 4, so I have 4i I squared. And then if you recall, we can do some simplifying here because I squared equals a negative 1. So to simplify, I really have 10I plus 4 times negative 1. My final answer, and again, you want to put it in A plus BI form, so I'm going to make it negative 4 plus 10I. And that's my final answer. So really what you're looking for here when we multiply is, do you have I squared or I to the 4th power, which you can then convert either to negative 1 or 1 and simplify. Now for D, we're going to do FOIL. Okay. So we're going to start off and we'll do 7 times 2, which is 14. Then we'll do 7 times 4I, which will give me a positive 28I. Next, I will do negative 3I plus 2, so I'll get negative 6I. And last, I'm going to do negative 3I plus, or times 4I, so it'll give me a negative 12I squared. Last thing we want to do, combine like terms and eliminate my I squared. Again, that I squared equals a negative 1. So I really have 14 plus 28I minus 6I will give me 22I. And I have a negative 12 times a negative 1. And that negative 12 times negative 1 will give me a positive 12. So I have 14 plus 22I plus 12. And the last thing I can do is add the 14 and the 12 together. So I will get 26 plus 22I. All right, we're going to continue with our multiplying. For E, we're going to multiply two binomials together. So again, I'll do FOIL. And I have, first, I'll do the square root of 8 times the square root of 2, which 8 times 2 will give me 16. So I have the square root of 16, and I'm going to simplify later. Then I'm going to do the square root of 8 times the square root, or times negative 7I. So it will give me negative 7I square root 8. You want to put the radical second. When we do our inner terms, I'll do 2I times the square root of 2. So it will give me a positive 2I square root 2. And then my last terms, 2I times negative 7I will be negative 14I squared. And from there, we're going to simplify. So the square root of 16 is 4. And I know that the square root of 8, if I put it up here, can simplify to the square root of 4 square root of 4, times the square root of 2. And the square root of 4 is 2, so I get 2 square root 2. I'm going to take this 2 and multiply it times my 7, so I'll get negative 14I square root 2 plus 2I square root 2. And my minus 14I squared, remember, this is a negative 1. So negative 14 times negative 1 will give me a positive 14. And then I'm going to continue to simplify. I can add 4 plus 14. It will give me 18. And negative 14I plus 2I will give me a negative 12I square root 2. Because again, we had i's in both terms and the square root of 2, so we could add them together. So my final answer is 18, 12I square root 2. For F, it is 6 minus 3I squared. So I'm going to write it out because we're squaring the binomial, so we're going to write it twice. And we'll start with 6 times 6, so we get 36. And then 6 times negative 3i, so it'll be negative 18i. And then here we'll have negative 3i times 6, so I get negative 18i. And my last terms, negative 3i times negative 3i, will give me a positive 9i squared. And I want to simplify, so I'm going to have 36. Negative 18 plus negative 18 is negative 36i. And again, we have positive 9, but it's 9 times a negative 1, because I squared equals negative 1. So it's going to be minus 9 here. And I'm going to combine 36 minus 9, which will give me 27. So I'll have 27 minus 36i. Now, for g, you may say, well, this looks like there's nothing I can do. It's 6 divided by I. That is correct, and there's no actual division we can do right now. But they want us to simplify and write our answer in standard form. So our answer has to be in A plus BI form. So to do this, what we're going to do is we are going to multiply both the numerator and the denominator by the conjugate of the denominator. So remember, the conjugate of an expression, like the conjugate of A plus BI, would be A minus BI. Now, here, we only have I in our denominator, so the conjugate of it would be a negative I. So we're going to multiply both the top and the bottom by negative I. And when I do that, on the top I will get negative 6i, and the bottom it will be negative I squared. And we do know that I squared equals a negative 1. And I have a negative there, so if I have the opposite of negative 1, it's going to give me a positive 1 on the bottom. And on the top, I can't really do anything with negative 6i, so I'll leave it as is. So my answer is negative 6i, or if you want to add in, we don't have a real number there, but it's just like having 0 plus negative 6i, or 0, I'll write it up here, 0 minus 6i. But we don't necessarily have to have the 0 there, so we could just write our answer as negative 6i. Now for h, again, we're going to use the conjugate of positive 4i. So our conjugate would be a negative 4i. So we're going to multiply the top and the bottom by negative 4i. So on the top, that's going to leave me with 28, negative 28i. On the bottom, I'm going to have negative 16i squared. Right now, for the top, I can't do anything, so I'll leave it as negative 28i. On the bottom, I squared, remember, is a negative 1, so I really have negative 16 times negative 1, which is going to leave me with a positive 16. And then I can divide my fraction to simplify it. So my final answer is going to be negative 7i over 4. Okay, and that's our final answer. Again, you can write it as 0 minus 7i over 4. That's okay. We just can't have an imaginary, we can't have an I in our denominator, so we have to get rid of that. All right, here for example I, we have another division problem, and we need to eliminate the I from our denominator. So we're going to start off and multiply the top and the bottom by the conjugate to 2i minus 1. So it's going to be 2i plus 1. And whatever I do to the bottom, I have to do to the top. So on the top, I'm going to go ahead and distribute. And that will leave me with 6i plus 3. And they're not like terms, so I'm done there. Now on the bottom, when I multiply, 2i times 2i will give me 4i squared. 2i times 1 will give me plus 2i. Negative 1 times 2i will give me negative 2i. And negative 1 times a positive 1 will give me a negative 1. And the nice thing here is those middle terms, 2i and negative 2i, they equal 0, so they cancel out. And I also know that 4i squared is negative 1, so 4 times negative 1 will give me negative 4. And I still have my minus 1. So my denominator is going to end up being a negative 5. So right now I have this. I have 6i plus 3 over negative 5. And the last thing we want to do is write it in a plus bi form. We do have a fraction here, but we need two separate fractions. We need to have the real number part and the imaginary part. So I'm going to put my answer as negative 3 over 5 plus, or actually in this case we can make it minus because it's a negative 5. So let me erase that. So minus 6i over 5. And I just distributed the negative to both numerators. So this is my final answer in a plus bi form. All right, we have one last one where we're going to do the same thing that we did with I. And we're going to multiply the top and the bottom by the conjugate to 1 plus I. So it's going to be 1 minus I. And I'm going to go ahead on the top and FOIL. So 3 times 1 will give me 3. 3 times negative I will be a minus 3i. 5i times 1 will give me plus 5i. And 5i times a negative I will be a negative 5i squared. On the bottom, when we multiply, 1 times 1 gives me 1. 1 times the negative I will give me a negative I. Positive I times 1 will give me plus I. And positive I times negative I will give me a negative I squared. And the last thing we need to do is simplify. So on the top, we have 3. Now, negative 3i plus positive 5i. They're like terms, so I can combine them. And I get plus 2i. And negative 5 times a negative 1, because I squared equals that negative 1, is going to give me a positive 5, which I can then simplify. 3 plus 5 gives me 8, so I have 8 plus 2i. We got to worry about our denominator now. In the middle, if you notice, negative I plus positive I will cancel, and I have 1, and it's minus I squared, but I squared equals a negative 1. A negative times a negative gives me a positive 1. So I'm going to have 8 plus 2i over 2. And then the next thing we're going to do is write it in a plus bi form. So we're going to separate it into two separate fractions. I'll have 8 over 2, plus 2i over 2. And if you notice, we can simplify our fractions. So 8 over 2, when that simplifies, it equals 4. And 2 over 2, this equals a 1, so I'm left with just plus I. So our final answer is 4 plus I. Now we're looking at the square root principle. And the square root principle says that if you have x squared equal to c, so x squared is equal to any real number, then your x is going to be equal to the positive and negative square root of c. So we're going to solve some equations using our square root principle. And the first thing we're going to do here, the a is nice and easy because it's x squared equals 121. So to find x, we're simply going to take the square root of both sides. The square root of x squared is x. The square root of 121 is going to be a positive or a negative 11. And you can write your answer just like that. It's two solutions, positive 11 and negative 11, but we can leave it in that form. B, again, we're going to take the square root of both sides using our square root principle. And I'm going to get x is equal to the positive and negative square root of 18. But I can simplify my 18. If you recall, the square root of 9 times the square root of 2. So we're going to do x is equal to the positive and negative square, or 3, so the square root of 9 is 3, times the square root of 2. So my final answer is the positive and negative 3 square root 2. Now what we want to do for C, before we solve it, is we want to isolate our x squared. So we want to kind of solve the equation for x squared first, and then take our square root of both sides. So I'm going to start off and add 15 to both sides. And that will leave me with 5x squared equals 15. And then I'll divide both sides by 5. And I get x squared is equal to 3. Now, because I'm down to x squared, I can take the square root of both sides, and I will get x is equal to the positive and negative square root of 3. And there's no breaking it down, so that's my final answer. All right, C, let's see here. For D, we want to, again, break it down. I'm going to make a box here so we can do our work in there. All right. First thing I'm going to do is combine my x squareds to a single x squared. So I'm going to subtract 4x squared from both sides. And that will give me 2x squared minus 10 is equal to 6. Then I'm going to add 10 to both sides. So I get 2x squared is equal to 16. Divide by 2. We get x squared is equal to 8. And then we'll take the square root of both sides. So we have x squared is equal to the positive and negative square root of 8. But again, we can break down the square root of 8 and turn it into, it's equal to the square root of 4 times the square root of 2, or 2 square root 2. So x is equal to the positive and negative 2 square root 2. And that's my final answer there. All right, now for E, this one's special in the case that we don't have to, we have x plus 6, this entire binomial is squared. Because that expression is squared and it's isolated by itself, we are going to do our square root principle right there. So what we're going to do is we're going to take the square root of x x plus 6 squared and the square root of 3. So when I take the square root of x plus 6 squared, remember it just gives you x plus 6, and that'll be equal to the positive and negative square root of 3. Now I'm solving just for x, so I need to isolate it. So to finish it off, I'm going to subtract 6 from both sides. And my final answer will be negative 6 plus or minus the square root of 3. F is very similar to E. Again, this expression is squared, so to solve it, we're going to take the square roots of both sides. When you take the square root of something squared, you get what's under the radical, so we'll have 4x minus 5 is equal to the positive and negative square root of 6. Again, we want to isolate x, so I'm going to start by adding 5 to both sides, which leaves me with 4x is equal to 5 plus or minus the square root of 6. And then we have to divide everything by 4. So we will get x equals 5 plus or minus the square root of 6 over 4. Now, if I could simplify like 5 over 4, I would write it as two fractions and do that. But in this case, so I could write it like this. I could make it 5 over 4 plus or minus the square root of 6 over 4. But I can't do any simplifying, so leaving it as 1 is okay. But if you could simplify, that's when you want to break it into 2 and do that. Right, now we're going to be solving a quadratics that we can't necessarily factor. Sometimes we can, but we can also solve them by completing the square. It's another way to solve a quadratic. And when you solve by completing the square, you're creating a perfect square trinomial. And your perfect square trinomial is a trinomial that's either going to be in the form of a squared plus ab plus b squared, or a squared minus ab plus b squared. And once they're in this form, they're very easy to factor because they will factor either as a plus b squared for the first one or a minus b squared for the second one. So in order to do completing the square, the first thing you need to do is write your equation in the form of ax squared plus bx equals c. So ax squared plus bx equals c. In other words, you want to take that constant term, that c term, and move it over to the right-hand side of your equation. So you don't want it equal to 0 now. You want it equal to that c term. And once you do that, which for a, that's already done for us, what we're going to do now is we are going to create our perfect square trinomial by taking half of my middle coefficient, or my b term. So we're going to take b, divide it by 2, and then we're going to square it and add it to both sides. So I'm going to have x squared plus 4x, so we keep that. And then when I take my middle term, or b, I have 4. If I take 4 and divide it by 2, it gives me 2. And then I square that, I get a 4. So I'm going to have x squared plus 4x plus 4. And I'm going to add that to both sides. So I'll also have 15 plus 4. Now I'm going to simplify, and I want to, let me make that a better plus sign there. factor the left-hand side. X squared plus 4x plus 4 will factor to x plus 2 times x plus 2. And it's going to equal 19. X plus 2 times x plus 2 is the same as x plus 2 squared equals 19. And the nice thing here is we've done the square root principle. We know that now because I have x plus 2 squared, I can solve this by taking the square root of both sides. When I take the square root of x plus 2 squared, I get x plus 2. And it's going to be equal to positive and negative square root 19. And then again, you want to isolate the x, so we're going to subtract 2 from both sides. And my final answer will be negative 2 plus or minus the square root of 19. And I can't do any more, so that's my solution. The key to this is remembering to take that middle term, have it, and then square what you get when you divide it by 2. All right, so for b, again, it's already in the form of ax squared plus bx equals c. So they move the c term over to the other side. Right now I need to figure out what I'm going to add to both sides. My middle term is negative 12. So I'm going to take negative 12 divided by 2, and I get negative 6. But when I square negative 6, it's going to give me a positive 36. So I'm going to add 36 to both sides. So I'll have x squared minus 12x plus 36 is equal to negative 28 plus 36. Now what I need to do is factor that left side. X squared minus 12x plus 36. That's going to factor to x minus 6 times x minus 6. And it will be equal to negative 28 plus 36 will give me a positive 8. X minus 6 times x minus 6 is the same as having x minus 6 squared is equal to 8. And now what I'm going to do is take the square root of both sides. So the square root of x minus 6 squared is x minus 6. And we're going to get the positive and negative square root of 8. Now I do have a little bit of work to do here. First, I'm going to isolate the x by adding 6 to both sides. So I get x equals 6 plus or minus the square root of 8. But the square root of 8 I can simplify. If you recall, it equals the square root of 4 times the square root of 2. And the square root of 4 is 2. So my final answer is going to be x equals 6 plus or minus 2 square root 2. So that's my final answer. Okay, now for C, we're going to go ahead and solve this. And the first thing we need to do to complete our square is move our C term to the other side because they have x squared plus x minus 9. So we just need to add 9 to both sides to move that C term to the right-hand side. Get it away from the x squared. So when I do that, I'm going to be left with x squared plus x equals 9. Now I got to find what I'm going to add to both sides. If I look at my b term, it's just an x. But if you recall, my coefficient in front of that x is a 1. So if I take 1 and divide it by 2, I get 1/2 or 0.5. If it helps, we'll look at that. Then we have to square that. If you square 5/10, you get 25/100. So that's what I'm going to add to both sides. I'm going to take my x squared plus x and add 25 hundredths to both sides. And then I'm going to go ahead and factor the left side, which will factor to x plus 5/10 squared is equal to 9 and 25 hundredths. And then again, we want to solve for x, so we're going to do our square root principle, take the square root of both sides. And that will leave me with x plus 5/10 is equal to the positive and negative square root of 9 and 25 hundredths. And we're going to go ahead and subtract 5/10 from both sides. So my final answer will be x is equal to negative 5/10 plus or minus the square root of 9 and 25 hundredths. And that's our final answer. We can't do any more. Now for D, again, we have to start by moving our C term over. So I'm going to subtract 1 from both sides. And that will leave me with x squared minus 7x equals a negative 1. Then my B term is a negative 7. So I'm going to take a negative 7, or 7, and divide it by 2. I get negative 3.5. And then I have to square that. So when I square that, it gives me 12 and 25 hundredths. So that's what I'm going to add to both sides. So I'm going to take x squared minus 7x and add 12 and 25 hundredths plus, or is equal to negative 1 plus 12 and 25 hundredths. And when we factor the left side, we're going to have x minus 3.5 squared is equal to 11 and 25 hundredths when I simplify the right side. We'll take the square root of both. So I'm going to get x minus 3 and 5/10 is equal to the positive and negative square root of 11 and 25 hundredths. Then I will add 3 and 5/10 to both sides so that I can isolate x. And I will get x equals 3 and 5/10 plus or minus the square root of 11 and 25 hundredths. And that's our final answer. We can't do any more. All right. Now for E, we have 3x squared plus 6x equals 4. And in order to factor this as a perfect square trinomial, we need to have x squared by itself, not with a 3 or no, we don't want a coefficient other than 1. So the first thing we're going to do is get rid of that 3 with the x squared. And we're going to do that by dividing all 3 of the terms by 3. When I do that, it's going to leave me with x squared plus 2x equals 4/3. And that's better because now we have just x squared there. B is 2. So if I take half of 2, 2 divided by 2 gives me 1, and I square 1, I get a 1. So I'm going to add 1 to both sides. So I'm going to have x squared plus 2x plus 1 on the left side. And then I'm going to do 4/3 plus 1. But because I'm adding fractions here, instead of doing 1, I'm going to make it into a fraction. I'm going to turn it into 3 over 3. Because remember, the same thing on the top and the bottom is equal to 1. And then I'm going to go ahead and factor the left side. So x squared plus 2x plus 1 will factor to x plus 1 squared. And that's going to be equal to 7/3 when I add the other side. Now we're going to take the square root of both sides. So I'll have x plus 1 is equal to the positive and negative square root of 7/3. Then I'll subtract 1 from both sides. So I get x is equal to negative 1 plus or minus the square root of 7/3. But the last thing that we need to take care of is I can't leave a denominator with a radical. I have to rationalize that denominator. So we're going to simplify this, or we're going to make it x equals negative 1 plus or minus the square root of 7 over the square root of 3. And remember, to rationalize your denominator, we're going to multiply by our denominator. So we're going to multiply by the square root of 3. And that will give you a final answer of x equals negative 1 plus or minus the square root of 21 over 3. And from there, we can't do anything else, so that will be my final answer. All right, we're going to take a look at F. And again, we're going to start off doing the same thing that we've done before, and we want to make C be on the right-hand side, not the left. So I'm going to add 3 to both sides. So that leaves me with 5x squared minus 20x is equal to 3. And I want x squared by itself so I can factor it easily. So I'm going to divide both sides by 5, or all 3 terms by 5. So that leaves me with x squared minus 4x is equal to 3/5. And then I have to find out what I'm going to add to both sides to complete my square. Half of 4 is 2, and 2 squared is 4. So we'll have x squared minus 4x plus 4 is equal to 3/5 plus 4. And again, that 4, to kind of help us fraction-wise, I'm going to take it and convert it into a fraction with a denominator of 5. So if you recall, if we have 4 over 1 and I want to make it have a denominator of 5, that means I multiplied this by 5, so I multiplied that by 5, so it's going to be 20 over 5. So I'll add 20 over 5 here. When I factor the left-hand side, I will get x minus 2 squared is equal to 23 over 5. And then we'll take the square root of both sides. And I'll have x minus 2 is equal to positive and negative square root of 23 over 5. We'll add 2 to both sides. So I get x is equal to 2 plus or minus the square root of 23. And I'm going to separate it now over the square root of 5. Then I need to rationalize my denominator, so I'll multiply both the top and the bottom by the square root of 5. And my final answer is going to be x equals 2 plus or minus the square root of 115, which is 23 times 5, over 5. And that's my final answer. All right, our final section that we're going to look at today is solving quadratics with complex roots, which means this time our solutions are not going to have all real numbers in it. We're going to deal with that imaginary unit of I. So we're going to have a negative under the radical for these solutions. We're still going to use our same 3 ways to solve a quadratic. We're going to solve first by the square root principle, next by completing the square, and then the quadratic formula. So for A, they want us to solve by using the square root principle. I already have x squared isolated, so I'm simply going to take the square root of both sides, and the square root of x squared is x. Now this time, the square root of 16 is 4, and then we have to convert it into, remember, the square root of I times the square root of 16. So our answer is going to be positive and negative for I. And that's all for that one. So nice and easy. B, of course, is not that easy. We still have to do a little bit of work. First thing we're going to do is get our x's together. So I'm going to add x squared to both sides. And that's going to leave me with 9x squared plus 12 is equal to 0. I will subtract 12 from both sides, and I get 9x squared equals negative 12. Then again, we want the x squared by itself, so we're going to divide both sides by 9, and I get x squared equals negative. Then I'm going to simplify 9/12 by dividing 3 out of it, so it becomes 4/3. Now, to find x, I'll take the square root of both sides. So I get x equals the positive and negative square root of, here, I'm going to separate it, and I'm going to make it negative 4 over the square root of 3. And I know that the square root of negative 4 is going to be positive or negative square root of, or it's going to be the square root of negative 4 is 2i over the square root of 3. And then the last thing we need to do is, because again, we don't want a radical in our denominator, is we're going to rationalize by multiplying both the top and the bottom by the square root of 3. So I will have x equals the positive and negative square root, or the positive and negative root of 2i square root 3 over 3. And that's my final answer. Because remember, the square root of 3 times the square root of 3 gives me the square root of 9, which simplifies to 3. And that's my final answer. I can't do any more. Okay, so A here, we're solving by completing the square. Again, we're just not going to have a real number answer. We're going to have a complex root. So that means we'll use some imaginary numbers in there. First thing I want to do is move my c term to the other side. So I'll subtract 28 from both sides. And that will leave me with x squared plus 10x is equal to negative 28. Then I need to figure out what I'm going to add to both sides to complete my square. My b term is 10. 10 divided by 2 is 5. And when I square that, I get 25. So that's what I'm going to add to both sides. So I'll have x squared plus 10x fix that for you. Plus 25 is equal to negative 28 plus 25. When I factor x squared plus 10x plus 25, I'm going to get x plus 5 squared, and that will be equal to a negative 3. Now, I'm going to go ahead and take the square root of both sides. So I will have x plus 5 is equal to the positive and negative square root of negative 3. And I'm going to go ahead and move the 5 over to the other side. So I'll have x equals negative 5 plus or minus. And my square root of negative 3, I can't leave the negative under the radical, so I'm going to make the negative 1 into an I and leave the square root of 3. So my final answer is negative 5 plus or minus I square root 3. To solve B, the nice thing is they already moved C to the other side, but we have a 2 with my x squared. So again, we're going to start off by dividing everything by 2 to get rid of that 2 with the x squared. So it's going to leave me with x squared plus 3 halves. So we have 3 halves x, and it's going to be equal to negative 7 over 2. Now I need to find my B term here. So if I take, I'm going to write down here so I have space, 3 halves, and I want to divide it by 2. So if I divide this by 2, remember it's the same as multiplying by the reciprocal when you deal with fractions. So I'm going to multiply by 1/2, and it's going to give me 3/4, which I have to now square. When you square 3/4, you do 3/4 times 3/4, and it will give me 9/16. So that's what I'm going to add to both sides. I'm going to do x squared plus 3 halves x plus 9/16 is equal to negative 7 over 2 plus 9/16. Now when I factor the left-hand side, I will get x plus 3/4 squared is equal to, and then on the other side, when I changed my negative 7 over 2 to a denominator of 16, that's going to be multiplied by 8, so I get negative 56 over 16. Negative 56 plus 9/16, or negative 56/16 plus 9/16 will give me negative 47 over 16. And then we take the square root of both sides. So I get x plus 3/4 is equal to the positive and negative square root of negative 47/16. And I'm going to subtract 3/4 from both sides. So I will get x is equal to 3/4, and it's a negative 3/4 because I subtracted it, plus or minus the square root of negative 47 over the square root of 16. Since I have to rationalize, I'm going to separate it. Now, it's nice because the square root of 16 is 4, so that simplifies easily. And the square root of 47, I really can't do anything with it except I can get rid of that negative underneath there by pulling out I. So I'll have I square root 47. And I'll keep my plus or minus and my negative 3/4. So my final answer is x equals negative 3/4 plus or minus I square root of 47 divided by 4. All right, on our last two examples, we are going to solve them using our quadratic formula. So if you recall, our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Remember, a is the x squared term, b is the x term, and c is your constant term. When you solve a quadratic, you want to make sure it's equal to 0 before you put it into the formula. And you want to make sure that you know what's a, what's b, and what's c. So for our first problem here, 12 is going to be my a, negative 4 will be my b, and c is 5. And I'm going to plug the numbers into the formula. We don't worry about the x squared or the x. So I will have x is equal to the opposite of b. So my b is negative 4. The opposite would be 4. Plus or minus, and then we're going to do our square root. B squared, so negative 4 squared is 16. Minus 4 times a, which is 12, times 5, which is c, all over 2 times a, or 2 times 12 in our case. So we're going to get x is equal to 4 plus or minus, and then under the radical, let's see here, negative 4 times 12 times 5 will give me negative 240. So we have 16 minus 240 all over 24 because I did 2 times 12. So I'm going to get x is equal to 4 plus or minus the square root of 16 minus 240 is negative 224. And all over 24. Now what we want to do is, one, we have to worry about that negative number under the radical. We have to pull that out. And I also need 224. I know it can be simplified, so we got to figure out 224, what perfect square goes into it. I know that 4 will go into it, but I think there's a higher one. If I take 224 and divide it by 16, I get 14. So we're going to break this down, and it's going to become 4 plus or minus, and I'm going to make it I, so I pulled out the negative, times the square root of 16 times the square root of 14 over 24. And when I simplify that, it is going to give me x equals 4 plus or minus 4i square root of 14 over 24. And again, because we have that I, we can separate it into a plus bi. So we want two separate fractions. So we'll have x equals 4 over 24 plus or minus 4i square root of 14 over 24. And I can simplify that fraction. 4 over 24 becomes 1/6 plus or minus 4 over 24 again becomes 1/6. So I can make it I square root 14 over 6 because it's 1i, but I don't need to put the 1 there. And that is my final answer. All right, now we're going to look at our last example for this section. And since we're doing the quadratic formula, this one needs to be written in ax squared plus bx plus c form. So I need to move my 6 over to the other side and make my equation equal to 0. So when I do that, I'm going to have negative 5x squared plus 4x minus 6 is equal to 0. And now I'm going to plug my values into my quadratic equation. So I will have the opposite of 4 is negative 4 plus or minus 4 squared is 16 minus 4 times negative 5 times negative 6 all over 2 times negative 5. So I will have x equals negative 4 plus or minus the square root of, and I'm going to do negative 4 times negative 5 times negative 6 at negative 120. 16 minus 120 is negative 104. And 2 times negative 5 is negative 10. So again, I need to worry about that negative under the radical and simplifying that 104. 104, I divide it by 4, I get 26. And I think that's as far as we can go. So I'm going to break it down. I'm going to make it x equals negative 4 over negative 10. So I'm going to break it down further. Plus or minus my square root of negative 104. I'm going to make it I times the square root of 4 times the square root of 26 over your negative 10. And then I'm going to simplify it further. I will get x equals, my negative 4 over negative 10 will simplify to 2/5, and it's going to be positive because we have the two negatives and they make a positive. And then on the other side we'll have plus or minus. It will be 2i square root 26 over negative 10. But the 2 and the negative 10 we can simplify. So we're going to end up with 2/5 plus or minus I square root 26 over 5. So pull out that negative. And that's our final answer.